In this video we're going to look at matrix multiplication. In this first example we're going to multiply a 2 by 3 matrix with a 3 by 2 matrix. Now because the number of columns in the first matrix is equal to the number of rows in the second matrix, that is 3, we can perform this multiplication and the end result will be a 2 by 2 matrix given by this number and this number. So let's start performing this multiplication. I'm going to set up a big matrix here with enough space to do the working. So to get the number in row 1 column 1, we need to multiply the first row by the first column. So that means 1 times 7, which is 7, plus 0 times 6, which is 0, plus 1 times 5 is 5. So adding those up, that means that number will be 12. To produce the number that goes on the first row in the second column, we need to multiply the first row from the first matrix by the second column in the second matrix. So it will be 1 times 3, which is 3, plus 0 times 0, which is 0, plus 1 times negative 2, which is negative 2, or we'll write it as subtract 2. Then 3 take away 2 is 1. So that is a 1 in that position. Now we want to work out what number goes in row 2 and the first column. So that means we'll need to multiply the second row by the first column. So that's 2 times 7, which is 14. Then minus 1 times 6, which is take away 6. And 3 times 5 is 15, and that adds to 23. Then to get the number that goes in on the second row, second column, we need to multiply the second row from the first matrix by the second column from the second matrix. So that will be 2 times 3, which is 6, minus 1 times 0 is 0, and 3 times negative 2 is negative 6. So that comes out at 0. So basically the result of the multiplication is 12, 1, 23, 0. Now moving on to the second one, we have a 1 by 4 matrix multiplied by a 2 by 1. This is impossible because the number of rows in the first number of columns in the first matrix isn't equal to the number of rows in the second matrix. So moving along, this time we're going to multiply a 2 by 2 by a 2 by 2. So that means the result will be a 2 by 2 as well. So the number that goes in the first row, first column will be multiplying the first row by the first column. So 1 times 3 is 3, plus 3 times 4 is 12. So that's 15. The number that goes in the first row, second column, will be the first row from the first matrix and the second column from the second matrix. So 1 times negative 2 is negative 2, plus 3 times 0 is 0, so that's negative 2. Then, to find the number that goes in the second row, first column, we need to multiply the second row by the first column. So negative 2 times 3 is negative 6, plus 6 times 4 is 24, so that comes out at 18. Now to get the number that goes in on the second row, second column, we need to multiply the second row by the second column. Negative 2 times negative 2 is 4, plus 6 times 0 is 0, so that's equal to 4. So that gives us 15, negative 2, 18 and 4. Now moving to the next one, which is another 2 by 2 matrix. This time we're being asked to comment on the result, and I might do this one just a little bit quicker. So on the first row, first column, we need to multiply the first row by the first column. So minus 2 times minus 4 is 8, and minus 1 times 7 is take 7, so that's 1. Then the first row by the second column, minus 2 times minus 1 is 2. Subtract, it will end up being subtract 1 times minus 2 is minus 2, so that's 0. Then the second row, first column, needs the second row in the first column. 7 times minus 4 is minus 28, and then 4 times 7 is plus 28, and that equals 0. And then second row, second column, we need the second row and the second column. So 7 times minus 1 is minus 7, and 4 times 2 is 8, so plus 8, and that gives us 1. So that gives us the matrix, which is called the identity matrix. So the comment that you can make on this is that these matrices must be inverse to each other, because when you multiply inverse matrices you end up with the identity matrix.